Internal rate of return. The internal rate of return, the rate of return earned by the project based on cash flows, allowing for the time value of money. Internal rate of return is based on discounted cash flows. Unlike the net present value rule, however, it takes into account the project's scale. It is the discount cash flow equivalent to the accounting rates of return. Again, in general terms, the internal rate of return is that discount rate that makes the net present value of a project equal to zero. To illustrate, consider again the project described at the beginning of the net present value discussion. Cash flows, negative 4,567, internal rate of return 36.44. Here it is. Very simple with Excel. All you do is internal rate of return and then highlight your cash flows, and it's that simple to a point. Then we're going to run into a problem, and I'll explain it as we work through this discussion. As the internal rate of return, the net present value of the project is zero. The linkage between net present value and the internal rate of return is most obvious when the net present value is graphed as a function of the discount rate in net present value profile. Net present value profile for the project described is illustrated here. Net present value profile, this measures the sensitivity of the net present value to changes in the discount rates. The net present value profile provides several insights on the project's visibility. First, internal rate of return is clear from the graph. It is the point at which the profile crosses the x-axis. Second, it provides a measure of how sensitive the net present value and, by extension, the project decision is to changes in the discount rate. The net present value profile slope indicates how sensitive the project is to discount rates. Third, when mutually exclusive projects are being reviewed, graphing both the net present value profiles together provides a measure of the break-even discount rate, the rate at which the decision maker will be indifferent between the two projects. Using the IRR, the fact that the IRR can be applied even in examples when the discount rate is unknown is one of its advantages. While this is true for the calculation of the IRR, it is not true when the decision maker has to use the IRR to decide whether to take a project. At that stage in the process, the IRR has to be compared to the discount rate. If the IRR is greater than the discount rate, the project is a good one. Alternatively, the project should be rejected. The IRR can be worked out in one of two ways. The IRR can be calculated based on free cash flow to the company and the total capital contribution in the project. The IRR must be compared to the cost of capital in order to do this. The IRR can be calculated based on free cash flow to equity and the equity contribution in the project. If it is calculated with these cash flows, it has to be compared to the cost of equity, which should explain the riskiness of the project. Decision rules for independent projects. IRR is computed on cash flows to the currency. If the IRR is greater than the cost of capital, accept the project. If the IRR is less than the cost of capital, reject the project. B, IRR is computed on cash flows to equity. If the IRR is greater than the cost of equity, accept the project. If the IRR is less than the cost of equity, reject the project. The project with the higher internal rate of return is considered to be superior when two projects with equal risks are chosen. Estimating the IRR based on free cash flows, Granite Quick Charge. The cash flows to the company from Granite Quick Charge are used to arrive at a net present value profile as shown here. The internal rate of return in dollar terms on this project is 5.03%, which is lower than the cost of capital of 6.35%. These are consistent with the findings from the net present value rule, which also recommended not to invest in the battery quick charge market. Biases, limitations, and caveats. Internal rate of return is the most widely used discount cash flow rule in project analysis, but it does have some serious limitations. Because the IRR is a scaled measure, it tends to bias decision makers towards smaller projects, which are much more likely to yield higher returns and away from larger ones. There are a number of scenarios in which the IRR cannot be computed or is not meaningful as a decision tool. The first is when there is no or only a very small initial capital contribution and the cash flows are spread over time. In such cases, the IRR cannot be computed or, if computed, is likely to be meaningless. The second is when there is more than one internal rate of return for a project and it is not clear which one the decision maker should use. Multiple IRRs consider a project to manufacture and sell a consumer product with a hurdle rate of 12% that has 4-year life and the following cash flows over those 4 years. The project, which requires the licensing of a trademark, requires a large payment at the end of the 4th year. Image 6.3 shows the cash flows. We have negative million, 800,000, 800, 1,000, 1,300, negative 220. We have cash flows. We have negative 1,000, 800,000, 1,300, negative 2,200. The net present value profile for this project, shown in image 6.4, explains the problem that arises with the IRR measure. We have two internal rates of return. As you can see, the project has two internal rates of return, 6.60 and 36.55. Because the hurdle rate falls between these two IRRs, the decision on whether to take the project will depend on which IRR to use. To make the right decision in this case, the decision maker would have to look at the net present value profile. If, as in this case, the net present value is positive at the hurdle rate, the project should be accepted. If the net present value is negative at the hurdle rate, the project should be rejected. Multiple IRRs, what to do about them? Mathematically speaking, the IRR can be thought of as the root of the cash flow present value formula. In the conventional project, where there is an initial capital contribution and positive cash flows thereafter, there is one sign change in the cash flows and one root. That is, there is a unique internal rate of return. When there's more than one sign change in the cash flows, there will be more than one IRR. In image 6.4, for example, the cash flow change signs from negative to positive in year 1 and from positive to negative in year 4, leading to two internal rates of return. Lest this be viewed as some strange artifact that is unlikely to happen in the real world, note that many long-term projects require substantial reinvestments at intermediate points in the project, and that these reinvestments may cause the cash flows in those years to become negative. If this happens, the IRR approach may create problems. Several approaches have been proposed to solve the multiple IRR problems. One way to bring the negative cash flows from intermediate periods back to the present is to apply the hurdle rate. Making a net present value profile is an additional. Either way, calculating and using the NPV is most likely much easier. Brad Williams, Frugal Finance. Thanks for watching.